MAPECU ECU Configuration Part 3. In Part 1 we covered the General tab, Part 2 we covered TPS and nitrous, and in Part 3 we're going to cover the fuel cut defeat, electronic boost control and NOT configuration. Fuel cut defeat, we have two fuel cut defeats which are independent. These are completely independent of the MAF clamp that I showed you in Part 1. These are programmed as input and outputs, which I'll show you later in the I/O function. But what you do is you set a clamp voltage, which is in a manual or an old school fuel cut defeat is generally a rotary potentiometer or something like that. In this case, channel 1 is set to 4.3 volts, so you can set it in 0.1 increments as per the helper text. And then a unique feature which of the MAPECU3 fuel cut defeat is a release pressure. So this means you're effectively raising fuel cut, retaining it and raising it. So it's not just a defeat, it's another protection mechanism, so that, for example, if you've raised your boost from stock 10 psi and you've now got a fueling system that can comfortably handle 20 psi, what you can do is set your fuel cut defeat to stop fuel cut at 10 psi, and that might be 4.3 volts as it would be for a Supra, for example. But then you say, I want to reenact fuel cut if I see 20 psi. So that means, or 21 psi in this instance. So you've got good fuel to 20, but if I hit 21 psi, I've got a problem. I'm going to run lean, so therefore I want fuel cut defeat to be deactivated, and I want a fuel cut again. So that's what the release pressure is. Fuel cut defeat 2 is exactly the same. You have another release function, you have another voltage setting. Now these are configured in the I/O screen, which we haven't covered yet, but I'll quickly show you that. The important thing you have to do with fuel cut defeat is map an input and an output. So in this case, I'll select the MAF input to be fuel cut defeat 1, and as the helper text says, that configures the MAF voltage input, orange wire on the 16-way harness to FCD1 function. Now I must configure a fuel cut defeat output. In this case, I'll select analog output 1, configure that to fuel cut defeat 1, and you'll see this helper text says it configures the black wire on the 18-way harness to be fuel cut defeat 1. So in this case, if, for example, on a Supra that uses a MAP sensor to control fuel cut or instigate fuel cut with the OEM ECU, you would cut that MAP sensor wire, connect the output of the MAP sensor to the orange wire on the 16-way harness, which is the fuel cut defeat input, then connect the OEM ECU side of that MAP sensor voltage or wire to the black wire on the 18-way harness. In that case, the MAP sensor voltage will go through the MAPECU3 without being affected until, as per the fuel cut parameters, you hit 4.3 volts, in which case it'll be clamped, and then if the MAPECU3 sees 21 psi or more, it'll release that clamp and you'll hit fuel cut again. So as I say, that's a unique function, the release feature, and there's two of these fuel cuts. If I wanted another fuel cut, I could configure it exactly the same way. Fuel cut defeat 2 is now configured to the external MAP sensor input, and analog output 2 I'll configure to fuel cut defeat 2. Simple mapping of two channels, so that's how you configure the fuel cut defeats. The next feature, electronic boost control. And this it's quite a raw electronic boost control in that it exposes all the settings. So for example, sensitivity, gain, mode, disabling over boost control, and a zone-based boost controller is more complicated than the average boost controller, but you can actually control boost a lot better, and you've got this table so you can actually configure it depending on RPM. Again, this MAPECU3 is set for a maximum RPM of 6,000, so hence the table is reconfigured from 600 to 6,000. And in this mode we've got it set to internal, which is a legacy setting. We generally recommend you use internal fast spool mode for an internal wastegate. So, starting with sensitivity. Sensitivity is related to boost pressure. So you'll see the first line of this table is boost pressure and 0.1 psi settings. So for example, if we set this to 20, and you've got to put the decimal point in, so I'm entering 200 here for 20. That's enough for this example. I entered too many zeros. So we've got 20 psi in these zones. So the sensitivity percentage at 80% says it will, in internal fast spool mode, open the boost control solenoid or start pulsing the duty cycle at 80% of target boost of 20. So at 16 psi, it'll start feeding pressure into the wastegate. So that's really important for fast spool mode. So what happens with fast spool is at 1 psi, 1 pound of boost, it will flick the or turn on the boost control solenoid, so stopping any pressure going to the wastegate. So it stops wastegate creep. And then at 80% of 20 psi, 16 psi in this case, it will start sending boost through to the wastegate to start the opening process, to give it time to start opening. Now if you've got a sluggish wastegate, you may want to change that to 60 for example, or 50 depending on the wastegate. So if it was set to 50 at 10 psi, it will start feeding pressure into the wastegate to get it moving. The thing that really determines boost is the duty cycle, the second row. So in this case, if I put in 50% duty cycle across the board, the most it will output to the wastegate is 50% duty cycle. So theoretically, if you've got a 10-pound wastegate spring and you want to run 20 pounds of boost, you'd run at 50%. Now nothing's linear, but it's a good starting point. What the third row is the calculated duty cycle. So what will happen in normal mode with the overboost control enabled, it will ramp up boost towards your target. If it overboosts, it will actually calculate and change the target duty. So effectively it copies the 50% into the bottom row, and then if it needs to reduce boost, it says I'm going to head over 20 pounds of boost, it will start winding the boost down, or the duty cycle down, to control boost, and you may find there's a 40% in this row, for example, where it's tried to control the boost or contain it. You can stop it doing that by checking the disable overboost control, in which case it's a plain vanilla duty cycle controlled boost controller, and that can be useful if you know the duty cycle and you're happy with the protection mechanism. The other feature or function I didn't mention was gain. This is the speed at which the boost controller recalculates. A value of 1 is 1/28th of a second. 3 is obviously 3 times that. So this is to stop hysteresis and so forth. So essentially, the slower the value, the faster the boost control, and it's good for setup work is to have it, for example, set to 1. So that's the boost controller. And the last thing for this part 3 is knock. Knock requires some external components and a knock sensor, of course, and essentially it's not really required when you've got a factory knock sensor, but in situations where the vehicle doesn't come with a knock sensor and you want to monitor knock, or you just want to monitor knock in the MAPECU3, you can connect the knock sensor as per the manual. You can set how sensitive you want it. You can get it to retard timing if it sees knock. Sensitivity tells it at what level of knock do you want me to reduce timing, and how long do I retard timing once I detect knock. And you can also set an RPM window. In this case, don't bother with detecting knock for below 3000 or above 7000, so that's programmable by the user.